Hello, ma'am. Assalamu alaikum. Today, my topic of discussion is RL Library, which is a high-level reinforcement learning library built on top of a distributed computing framework. It is a framework built for multiple reinforcement learning applications and to deploy it in the industry. I'll explain what RL Library is, how it works, what components it's made of, and how it is used in real-world scenarios. Firstly, we start with what is RL Library. Let's begin with the basics. बिल्कुल बुनियाद की बात करते हैं. RLLib is a open source reinforcement learning library developed by Anyscale and it is built on Ray. Ray is a framework for distributed computing, makes it easier to build RL special applications, etc. What makes RL library special is that it is designed to handle the complexities of reinforcement learning at scale, at a large scale. It takes care of parallel training, hardware resource management, and experiment execution, so users can focus more on designing and testing the RL algorithms. RL library supports different type of reinforcement learning tasks such as single agent, multi-agent, and offline learning. And even with custom workflows, which makes it very flexible, it is used for both academic research and production level projects. So why should we use RL library? There are several reasons why we, the developers and researchers, both choose RL library. First, it is a kind of a plug and play library. It is very easy. It provides ready to use implementations of popular algorithms, so you don't have to start from scratch. Secondly, RL library is distributed by default thanks to Ray. This means your training can scale from your laptop to a fully connected server cluster without rewriting your code. It supports many environments such as Gymnasium, Unity ML agents, and Petting Zoo, and even custom-built ones. RL Library also has a flexible API. You can use a simple configuration-based interface, or you can choose deeper and customize the low-level components to your liking. Plus, it integrates smoothly with Retune for hyperparameter tuning and includes features like logging, checkpointing, and model export. So it's production ready to use. Further, we'll check the key components of our library. Let's look into its architecture. It has four key components. First is the policies. This defines how an agent acts based on observation. Think of it as agent's brain. Policies can be simple or built using deep neural networks. Second is the environment. Environment is basically the simulated world the agent interacts with. It provides observations, rewards, and transitions. Next, we have rollouts. Rollouts are basically the collected experiences from the agent as it interacts with the environment. These are used to improve the policy. Finally, the trainer is the engine that runs the whole process. It manages rollout collection, policy optimization, checkpointing, and other things. These components work together in a training loop to continuously improve the agent's behavior. Now we'll check the workflow of RL ability. It's an overview how it works. So firstly, you start by setting up an environment like Cartpole or any other taxi environment or a custom one, whatever you like. You configure your training using a dictionary that specifies the algorithm, environment, and parameters. Then thirdly, you initialize a trainer object that handles the training process. The agent, nextly, the agent interacts with the environment and collects rollouts, updating the policy. And then when you collect the rollouts and update your policy, this is where the learning happens of the agent. This is where it is learning basically. Throughout the process, the RL library evaluates the agent performance and saves checkpoints for later. This one more thing about this is repeats, the loop continues until your agent performs well or meets your training criteria. It is powerful, and this basically is what makes RL library scalable and efficient. Uh, Now we'll talk about the supported algorithms. RL library includes a wide range of reinforcement learning algorithms, each suited for different problem types. PPO, or as we call it, proximal policy optimization, is a stable and versatile policy gradient method, or DQM, which is a deep queue network. It is great for problems which with discrete actions like game playing, Atari, etc. And SAC, which is your soft actor critic. Um, Soft actor critic is basically the best for continuous action control and balances exploration and exploitation. So I personally like SAC more. And there are more uh, more types of algorithms such as Impala, Apex, and others, which we can dive deeper into, but let's continue. So here's a training example, such as Cardpool agent, which is very wide and popular. We want to train an agent on in the Cardpool environment where it must balance a pole on a card. You can run this with just one line. RL library, which is a code line. Basically, you run the PPO on environment card pool. You train, run PPO on the environment card pool. It launches the PPO training and uses default configuration. Behind the scenes, RL library sets up an environment, creates a trainer, a PPO trainer, collects rollouts, performs learning, and logs the results. If you integrate it with Python, you have full control over your environment. You can modify the or customize the training loop however you like to your liking. There are yeah, custom environments as well. There aren't only your pre-built environments. You can create your own custom environment using Python. This only requires two methods, reset and step, just like an OpenAI Gymnasium. Our library also allows for custom policies. You can make your own policies, change them to however you like. You can design your own neural network or any logic that decides on how the agent acts, how it processes the environment, or even how it learns. This is extremely useful for research experimenting with new learning strategies or companies with unique problems that don't fit in the standard templates. Now we will go on to explain how Ray comes into action with the RL library and the basic leverage and advantage we have with Ray, which is scalability. It is one of it is one of RL library's biggest advantages, you can say, because it is built on RAID. It uses a system of remote actors and tasks that can run on multiple cores, GPUs, or even multiple machines. This makes it easier to train agents faster by collecting more experiences in parallel. And you don't have to worry about the scheduling, configurations, communication, the fault tolerance, or any distributed code that you have to write yourself because Ray handles all of it. This design allows you to scale your workloads easily from local testing to production scale distributing training. So it is easily deployable and works seamlessly. Finally we'll talk about some of the real world use cases of this, how RL library is actually used. And it is used in multiple fields, such as some of them are mentioned here, like robotics. It trains agent for tasks like robotic arm movement, walking, flying, etc. For vehicles as well, such as Tesla, the most popular example. Like it uses decision making, obstacle avoidance, and navigation. And in finance, it helps build smart trading agents that help adapt to dynamic market conditions as they're always and continuously fluctuating. In healthcare, it can be used for treatments as well, or how a patient is dosed for anything. So it automates the dosage planning. And in games such as we have non-playable characters, your NPCs, your pedestrians who walk in the game, who act based on the scenarios and situations, how you interact with them. So that for them, our library is also usable, and also it uses recommendation systems as well to personalize content for user based on changing behavior. This really shows how versatile RL library really is. Lastly, to summarize all of this, RL library is a powerful library that makes reinforcement learning more accessible, scalable, and customizable. It simplifies the training process while supporting many RL algorithms and environments. And lastly, thanks to Ray, it scales your training from a single machine to a larger cluster without changing your code. You don't have to worry about that. It is being used in diverse fields like robotic, gaming, healthcare, the ones I mentioned. It is, like if you can see that it is being used in real world, so it is not just for, research purposes, but to actually solve real world problems. If you are working in reinforcement learning or are trying to go into it, so it is highly recommended and definitely worth exploring the RL library. Thank you for listening. Jazakallah.